Okay, the limit of a function at c versus the value of the function at c. The study of limits is the understanding that the value of limit of f of x as x approaches c may be distinct from the value of the function at x is equal to c. That is f of c. This one. So we will consider the limit of 1 plus 3x as x approaches 2. So we have already constructed the table of values earlier. So here at the left side, as x approaches to 2, the f of x approaches to the value of 7. Same here at the right side, as x approaches to 2, the value of f of x approaches to 7. Therefore, the limit of 1 plus 3x as x approaches 2 is equal to 7. Now, let's check the value of the f of c. Now, the c is equal to 2. So, the f of 2. Using the function 1 plus 3x, or f of x is equal to 1 plus 3x, we will use that for our f of 2. F of 2 is equal to 1 plus 3 times x, or 2, that's equal to 7. So f of 2 is equal to 7. So therefore, the limit of the function and the f of c is the same in this example. Okay, for another example, the limit of x squared plus 1 as x approaches negative 1. So if we are to construct a table of values, we could see that as x approaches to negative 1, the value of f of x approaches to 2. And also in the right side, as x approaches to negative 1, the value of f of x approaches to 2. Therefore, the limit of the function is equal to 2. But how about the value of f of c? We could see that the c is equal to negative 1. So we will use the function x squared plus 1 to determine the value of f of c, or f of negative 1. So f of c is equal to x squared plus 1, or f of negative 1 is equal to negative 1 squared plus 1. So f of negative 1 is equal to 2. We can see here that the limit of the function and the f of c is equal to 2. So another example, limit of f of x as x approaches 4, where f of x is equal to x plus 1 if x is lesser than 4, and quantity of x minus 4 squared plus 3 if x is greater or equal to 4. Okay, so by constructing of table of values in left side and right side, we can see that as x approaches to 4, the value of f of x approaches to 5 here at the left side, while as x approaches to 4 at the right side, the value of f of x approaches to 3 at the right side. Therefore, the limit of in the left side and the limit in the right side are not equal. So the limit of f of x as x approaches 4 is d in e, or does not exist. Now, we knew the limit is d in e, but how about the f of c? The c here is equal to 4. So the f of c, or the f of 4. Now, according to our function, we will use the second equation if x is greater or equal to 4. Since our c is equal to 4, we will use the second equation, which is the quantity of x minus 4 squared plus 3. So the f of c is equal to quantity of x minus 4 squared plus 3. Or f of 4 is equal to 4 minus 4 squared, that's 0 squared plus 3. So f of 4 is equal to 3. Now, this is an example where the limit of f of x as x approaches c is different from the f of c. So the limit and the f of c are distinct. Now, in this activity, we will look or determine the limit of f of x as x approaches c versus the f of c by looking at the graph below. Okay, for number 1, we will determine the limit of f of x as x approaches negative 2 and the f of c or the f of negative 2. Number 2, the limit of f of x as x approaches 0 and the f of c is the f of 0. And number 3, the limit of f of x as x approaches 3 and the f of c or the f of 3. Okay, let's start with number 1. Limit of f of x as x approaches negative 2. So, we know this because this is the same graph as we have shown earlier. So, from here, we could determine that the limit from the left side is 1 and the limit from the right side approaches to negative 2 is also 1. Therefore, the limit is equal to 1. But how about the f of c? Now, the f of c here is here, the black dot. Therefore, f of negative 2 or the f of c is equal to 1 as well, where the y is equal to 1. Another one is the limit of f of x as x approaches 0 and the f of 0. Now we could see as we trace from the left side approaches to x is equal to 0, we could see that the y is equal to 3. Here at the right side, it's the same. As we trace from the right side, the graph approaches to x is equal to 0, is also approaches to y is equal to 3. Therefore, the limit is equal to 3. However, for the f of 0, we can see that this is a white dot. Therefore, there is no existing graph at this point. So, our f of 0 is undefined. Lastly, is number 3, limit of f of x as x approaches to 3 and the f of c or f of 3. Now, as we trace at x is equal to 3, in the left side, as our graph approaches to x is equal to 3, here at the left side, the y is equal to 0. While at the right side, as we trace the graph to x is equal to 3, we can see that the y is equal to 4. Therefore, the y is different from the left and also from the right. Therefore, the limit is DNA or does not exist. How about the f of c? Now, we could see that the f of c here is the black dot. This point is white dot, this point is white dot. These are undefined, but there is a particular black dot here. And the value of its y is equal to 2. Therefore, the f of 3 is equal to 2 or the f of c is equal to 2. So that's all. Thank you for listening. If you have further questions, just message me in the messenger. Thank you.